Hi guys, Dr. J here, and in this video I'm going to walk us through how to calculate some basic statistics in Python. Now, if you're completely new to Python, or maybe you've seen it but you haven't really done anything with it yourself, this video is for you. If you've used Python before quite a bit, or if you perhaps have it set up on your own computer, this is going to be a little bit basic for you. But what I want to do is just give us, everyone in the class, a chance to see how to do some basic statistics calculations in Python itself. And the way that we're going to do that is using something called Google Colab. So you can go to colab.research.google.com. And the reason I use Google Colab is because it basically lets us use Python for free without having to do any installations or setups or anything like that. So again, if you have used Python before or have some type of environment set up on your own computer, this is going to be a little bit basic, but this is for, especially for those who have never used Python before. So I'm going to call this Basic Stats Demo in Python. And you'll see that the layout here is very similar to other Google environments. By the way, I just clicked on a new notebook. But at any time you can come up here, open a notebook, create a new notebook, upload a notebook that you have. This is Google Colab, so we're in a browser. You can do this from any browser really, although I recommend Chrome. And now we can just start coding. And so we have here, we can add a code cell. We've already got one though, so we'll just go ahead and start with that. All right, so here we are. We're in this browser, but basically we're in a Python environment. So again, this is for those of you who are very new to Python. We need to set up the computer to receive our programming. The computer needs to know what language is being used. It needs to know how we're going to either compile or interpret that language. And so in this case, Google Colab has done a lot of the work for us by setting us up in this browser window. Python is already installed and working. So we can type in some Python and it will execute that code for us by pushing this play button once we get going here. Now, what is Python? It's a programming language. You can do lots of things with it, but one of the most basic things that you can do with Python is use it as a calculator. And that's what we're going to do in this video, basically. So let's just start here. I'm going to put in some basic math and 1 plus 1. If I push play, the computer is going to take this input, it's going to process it in Python, and you can see it gives an output here of 2. So even without doing anything else, just typing in 1 plus 1, we see the result is 2, and of course that's what we expect. We can do lots of other basic math operations. 5 times 6, there's the answer. We can do floor division, so 5 divided by 2 is going to be 2, because we have 2 goes into 5 twice, and then there's a remainder which we're ignoring. So this is called floor division. What else can we do? We can take a power symbol. For double star, 2 is the exponent. So here 2 is treated as an exponent. And Python follows all the basic rules. So 2 times 4 to the power 2 should be 32. And it is. Okay. And then same thing we can do just like a regular calculator with parentheses. If we wanted to now do the operation in this way, then we get 64, just like we expect. So it'll evaluate whatever's in parentheses first. So all of the normal order of operations that you're familiar with from algebra and calculus and graphing calculators, that all holds the same here. What if we want to do something a little bit more complicated than just basic math? Let's say that we have a whole bunch of numbers and we want to take the average. And so we're in this class on statistics. We want to calculate some statistics. One way to do that is by just putting the numbers into a list. So I'm going to use square brackets to create this list. And I'm going to put in some numbers here. And I'm going to separate those numbers by parentheses. So here's a list. And if I go ahead and run this cell, then you just see the list printed out. So this is a Python structure called a list, and it really just behaves exactly like what it sounds like. It's a list of items, and it doesn't have to be numbers, could be other items too, but in this case we're interested in statistics, so it's going to be numbers. We've got a bunch of numbers here, And these numbers are, you can see some numbers are repeated, they're all integers, they're all positive. So that might tell us something about where this data set came from. Maybe this is height in inches of a particular kind of plant, a very small plant. Maybe this is length in feet of sticks or something. It could be any number of things, but we want to calculate the average of this particular set of numbers. Now, of course, there are a number of ways to do this in Python. One way is to take those numbers out of a list. There we go. We're going to add all these numbers together. We can wrap that in a parenthesis. So this is no longer a list now. We're just doing this math operation like we were before. And then we need to see here, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 numbers. So we've got 14 numbers here. We're going to divide by 14. And there we go. Python has now given us the average, or we've calculated the average of these 14 numbers in Python. How about the variance? What if we wanted to calculate the variance? Well, the variance, right, is the sum of the squares of the differences between each one of these values and the average. So I'm just going to copy and paste this down here now. So there's our average. And I'm going to put in a comment here so I know what I'm talking about. Now, comments are important when you're writing really any code, but comments are just a way of putting in some text that's not going to be evaluated. Python's not going to do anything with that code. So I'm going to put a hashtag symbol. That's the symbol for a comment in Python. And I'm going to put, this is the mean of these 14 numbers, also known as the average. And now what we want to do is we want to calculate the variance of these 14 numbers. Now we've done variance, we can do variance in Google Sheets, we can do variance in a calculator. Here we're going to do it in Python. And so what we want to do now is take each one of these numbers and subtract off of each one. We're going to subtract off of each one the average, 2.07, and then square that, plus 4 minus 2.07 squared. And then we need to divide this whole thing by n, by 14. So we're going to take the mean squared deviation from the mean, and that will be our variance. So we have a variance of 1.23 something something. All right, so that was kind of painful to go through all of this because, we had to write all these things out, but we can do this. So Python allows us to use it like a calculator. We can just literally put in the numbers, add them up, divide, put in these numbers, do all the calculations to get the mean and the variance. By the way, we can also get the median, and to do that, we need to go back to the list form of these numbers. So we have here the list again, and what we need to do is put these, I'm just going to rearrange these numbers. I'm going to put them in order here, just by copying and pasting. So let me just make sure I didn't lose any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so there's my 14 numbers. We've sorted them. Same numbers. They're just in order now. And by the way, these spaces don't matter. So, oops. If I have extra spaces between two numbers, it doesn't really do anything. Okay, so I've got all these numbers now. I've got my 14 numbers in order. And remember we said the median is going to be the average of the two center numbers if you have an even number of values. So here we've got 14, so I'll count 1, 2, 3, 4, 5, 6, 7. 7 and 8, excuse me, are both 2. So actually the median. So the median here is going to just be 2 because that's the center value. It's the average of the two middle values in this case for even numbers. So we can do this kind of thing in Python. We can use Python as a calculator. But it's much easier actually to do something a little bit different where we define let's do this a little bit differently. So go ahead and run that cell. There's our list again. So we've got our numbers, we've got our mean, we've got our variance. Python allows us to calculate these basic statistics in a very easy way. And the way that we're going to do that mostly in this class is using functions. Now, functions is a little bit of an advanced topic. We're going to talk about this more later on. But suffice it to say for now, a function in Python is basically very similar to a function in mathematics. It takes an input and gives an output. So for example, one function that we can get in Python is the function print. And print just simply prints whatever you put inside of the parentheses. So all functions take these two parentheses, open and closed, and then in this case prints whatever is inside there. So if we print this list, let me go ahead and copy paste that into there, we'll get the same output actually as we had up here, because in this case Google Colab is just printing automatically what the final result is, but we can do it the same way by actually using the print function. Now it gets better than that though, because we can actually print the output of a calculation. So let me get rid of this and then paste our calculation. So this is now our calculation for the mean. So what do you think is going to come out of here? Is it going to be these numbers, or will it be the actual value? Well, let's find out. So let me run this cell again. And notice I have to rerun the cell in order for the result to show. And look at there, it is actually the result. So this print function takes whatever the output is of inside these parentheses and prints that out. So here print is a function. It's taking an input. In this case, the input could be a list. It could just be a single number. Let's just print the number 14 and voila, there it is, 14. Or it can even be a calculation where we could print this we could put this entire calculation inside of this print function and then get that result. You can play around with this and see what happens with putting different things inside that print function. Now there are also functions in Python for doing mathematics and calculating these basic statistics, but in order to use them, we have to have them available to us. So we didn't define this print function, we didn't import it or download it or anything like that. It was just available to us. And it turns out that that's the case with a bunch of different functions, but not all functions. So one function that's available that's a mathematics function would be abs, ABS. So this is going to take the absolute value of the argument. So if we say abs of -4, it will just give us +4. That's the absolute value. So some functions are available. If you want to see if a function's available, you can start typing its name. Doesn't look like square root's available. Let's see, how about the function sum? We can take, we want to be able to sum numbers. And so I see a sum, and then I see this weird thing about it. So we can use the question mark followed by the name of a function to find out more about what it does. This is true for all functions in Python when you're using Google Colab. So you can type question mark and then the function name, and it will show you what that function takes as inputs and what it gives as outputs. So here we're shown that it takes two inputs, an iterable and a start. Return the sum of start. So when you see the return name, that return is what the function gives as an output. So it's taking two inputs, one's called iterable, one's called start, and it gives an output, which is the sum of a start value, default 0, plus an iterable of numbers. Well, I don't know what that means, or at least I'm going to say that I don't for this video. So that doesn't sound like what we want to do for summing up numbers or calculating the average. And in fact, in order to use most math functions, we need to do what's called importing a library of math functions. Now, this is, again, going to sound a little bit complicated if you've never used Python, but basically all we're going to do now is get a bunch more functions like the print function, but that are more relevant for statistics and math. So we don't really need print too much in statistics and math. What we need is a bunch of statistics and math functions. Things like square roots and absolute values, medians, means, variances. We'd like to be able to use functions where we can take a list like this and just have it tell us what the value of the median is, what the value of the mean is, just by typing that function name down and hitting run. This is very similar to what you would do if you had a calculator. You would put in all the numbers to the calculator, and then you would ask the calculator to calculate some statistics for you from those numbers. A number of graphing calculators will do that. But in order to use those functions, we have to have them available. And so if I just type mean and say, let's just say, I'm going to say mean of 3 numbers, well, I'm going to get an error saying the name mean is not defined. And this is one big thing that you'll have to watch out for when you're doing programming is a lot of times you'll get these kinds of errors, and you have to kind of look and see what the problem was, what happened that gave you this error. So in this case, we see we have a name error. Name mean is not defined. We haven't defined what mean is. We just tried to type mean. Basically, we tried to use this function without defining it or importing it or downloading it, something like that. So what we need to do is actually import this function. So here's what we're going to do. We're going to type import numpy. And I'm going to run this. Now you say, how did I know how to do that? Well, numpy is a very well-known large Python package filled with functions. In fact, it's filled with functions for all kinds of things, everything from statistics and mathematics to some basic machine learning stuff to linear algebra. All kinds of interesting math-related functions are in the NumPy library. So now that we've imported this NumPy library, we can then use those functions that are in NumPy to do whatever math we want. And one of the functions in NumPy is a mean function. So now we're going to type numpy dot. And this dot is very important because basically it tells Python we're going to use the NumPy library and we're going to use a particular function from the NumPy library. And the function that we want to use, hopefully, if we can find it here, is the function mean. And actually you can see median there as well. But we'll go ahead and click on that. And now what we're going to do is put in this list. Well, before we do that, actually, whoops. Before we put in anything, let's look and see what this function does. We'll hit that question mark there, hit run, and it's going to pop up here with a help message for us. And it takes an argument called a, and then it has a whole bunch of these special looking arguments. And what does it say? Compute the arithmetic mean along the specified axis. So I don't know about the specified axis yet, but I see arithmetic mean. That's what I want. And what does it say it returns? It returns the average of the array elements. The average of the array elements. So A must be an array. The average is taken over the flattened array by default, otherwise over the specified axis. Float, 64, intermediate, blah, blah, blah. A bunch of stuff that I don't understand, but okay, that sounds promising. Let's try it out and see what happens. So what am I going to put into this function? Am I going to put a number? Well, the mean of, let's say, one number isn't very meaningful, so let me just try putting in some numbers. And, whoops, wrong button there. Let's try running that, see what happens. So I'm going to put in a bunch of numbers here, and it's going to think about it for a couple of minutes. And then it's going to give me a result, and already I see something's gone wrong. I see red there, and uh-oh, I got an error. And this is an axis error, axis 2. Axis was one of those arguments that it was talking about. I might need to go back and look. I haven't passed in an array. I need to pass in an array of numbers, not just a bunch of numbers separated by commas. So let me delete this. Now what is an array? An array in Python is like a list. So actually we have an array right here. An array is a set of numbers that are all grouped together, such as a list. There are other types of arrays too, but we're going to just talk about lists for right now. So I'm just going to copy and paste that list into here. That's actually what I was interested in the first place. And here we go. I'm going to run this cell. And we get the number. And lo and behold, it's the same number that we got before. We actually did the math right, so that's good. But now we've gotten something which is actually the mean, and we've figured out that in order to calculate the mean of any set of numbers, call this numpy function, numpy.mean, and then pass numpy.mean an array of numbers, which can be just a simple list, a list of the numbers that we have in order to calculate the mean. Now in this case, I'm not sure whether it was easier to calculate the mean of these numbers by hand or using the Python function, but you can see how to do this, and for much larger data sets, this is going to be a very useful thing for us to be able to do, to calculate the mean of a bunch of numbers without having to do it all by hand. The other thing that this allows us to do is to use all sorts of other functions that are available in NumPy, not just the mean, but let's see, how about the variance? So numpy.var, here's our array A again, and again here's all these weird other arguments that we're kind of ignoring. Compute the variance along the specified axis, returns the variance of the array elements, a measure of the spread of a distribution. Excellent, that's exactly what we wanted. So we're going to come back here, and we're going to put in our same array as before. Calculate that, and boom. Looks like we did our math correctly in both cases. We actually calculated the variance correctly, and now we're seeing that here from Python's function. So using just this simple function, numpy.var, we can eliminate having to do all this work, and the best thing is we can apply this to data sets which are even larger than these 14 numbers. So let's see. What have we done so far? We've opened up Python using Google Colab. We've calculated the mean and average of some numbers just by calculating. We can use Python as a calculator to do these basic sorts of calculations. We can create a list in Python, and then we can also import and use functions in Python to help us do things that, are just a little bit easier to do. It's easier to type numpy.mean and put in your list than it is to do all of this mathematics by hand. And just for completeness, let me go ahead and say numpy.median, because I noticed they had the median function there. We don't need to worry about the question mark. I'm pretty sure I know what the function median does. And it's going to do its thing. We'll put in the same list, and again, we get out the same result as we got before, 2. So we can use Python as a calculator. Using functions to apply to large data sets, we'll be able to make life easy on ourselves and do very complex calculations very easily. So I'm going to stop there for this video. We're going to talk a lot more about Python in this class, but for now I want you to just try it out. Go to Google Colab, again colab.research.google.com, or just do a Google search for Colab. You'll be able to open up a browser like this. You'll have to sign into your Google account. And then try putting in some basic calculations, arithmetic. Try importing the NumPy set of functions, and try using some functions in NumPy. Try looking for other functions that I haven't used here. All right, and that is all for this video. I will see you next time.